In this video, we're going to talk about domain and range of functions, and we're going to take up a number of different situations. Domain is a set of independent variable values for which the function is defined, for which the function exists and makes sense. And the range is a set of dependent variable values for which the function is defined. So in other words, the domain are all x values that work for a particular function, and the range is a set of all y values that work for a particular function. Here we can see that we're given a linear function, f of x equals 2x minus 1. If I look at a set of x values here, are there any restrictions that affect the graph? No, my function exists on every possible x value, so it extends forever from left to right. Therefore, the domain of this function is all real numbers, and the way we record it is this. D, which stands for domain, is x is all real numbers. R, capital R, represents real numbers. Now let's look at the range. Do we have any restrictions on the range? Are there any breaks in the function? Is our line split somewhere, or maybe there is an asymptote anywhere? No, our line is continuous and it goes on and on from bottom to the top, right? So for the range, there are also no restrictions, which means that every y value satisfies the equation of this function. So then range is given by R, and it's a set of y values that in this case could be any real number, YER. Another notation that we can use to represent domain and range is an interval notation. The one that we used just now is called a set notation. And an interval notation will mean the same thing, just written differently. So if our line extends indefinitely from left to right with no restrictions, we can say that the domain of such function goes from negative infinity to positive infinity. And if the range of our function extends forever from bottom to top, we can say that the range of such function goes from negative infinity to positive infinity. Now let's look at the following function. This is a quadratic function with a vertex at +1, -2. Let's state the domain and range for the following function. If I extended this function from left to right, it would go on indefinitely, continuously, without any breaks or restrictions. Therefore, the domain of this function is x is all real numbers. Now, if I look at the range of the function, I can see that my function goes down to -2, but it doesn't exist below this value. It only exists above this value. Therefore, I need to restrict the function range. So here I will say that y is all real numbers, but y has to be either equal to -2 or greater than -2. So that's my range. If I wanted to use an interval notation, then I would record it like this. The domain would still be going from negative infinity to positive infinity. There are no restrictions on the domain, but the range will be going from -2, including -2. So I will have a square bracket around the -2 and up towards positive infinity indefinitely. This is a square root function, and it has been shifted horizontally 2 units to the right. If I look at the graph of the following function carefully, I can clearly see that this function exists only on a certain domain, and it has restrictions, what x values are permissible. So if I look carefully at the x values, I can see that for the domain, the restrictions will be that x can be any real number, but it has to be either 2 or greater than 2. If the number that I have for the domain is negative or less than 2, then I will end up with a negative value under the square root, and there will be no real solutions. The function will not be defined. So I need to state the restrictions on the domain according to the following values. So then I can say that x is all real numbers, but x has to be greater or equal to 2. There are also restrictions on the range. My function exists only above the x-axis or at the x-axis. It does not exist below the x-axis. Therefore, only positive y values or 0 satisfy my function, but not negative ones. So I will say that y can be all real numbers, but y has to be greater or equal to 0. If I wanted to use an interval notation for these domain and range, then it will look like this. The domain has to go from +2, including +2, towards positive infinity. Infinity has always has a round bracket around it because it never ends. You cannot include it. And if I wanted to state my range using the interval notation, then again, I'm going to use square bracket to include 0 and towards positive infinity. Now let's look at another function, and it's a rational function. We have a reciprocal of a linear function, which is 1 over x. The graph of such function looks like this. We have two asymptotes, the vertical asymptote with an equation x equals 0, and a horizontal asymptote with an equation of y equals 0. An asymptote is a line that a function approaches but doesn't touch or cross. So how do we deal with such situation in terms of domain and range? We can exclude asymptotes from the domain and from the range and only keep all the other values. So the domain of the function will be any real number except x cannot equal 0. So in this case, we're only excluding the x equals 0, and anytime x equals 0, the function is undefined. And for the range, y can be any real number, but y cannot equal 0. Again, we're excluding the asymptote. Every other y value is possible. And if I wanted to state the same domain and range using the interval notation, I would have to go from -infinity to the asymptote, excluding the asymptote because at asymptote the function is undefined, in union with from the asymptote to positive infinity. And then for the range, again, my function will exist from -infinity to 0, excluding 0 because that's an asymptote, in union with 0 to positive infinity, all the way to the top of the graph.